Hi friends, I'm back. Today we're going to continue on Mission 3, Lesson 11, but this is actually going to be our lesson, not just our word problem. Our objective is the same. I can observe conservation of weight on the balance scale. So we're going to use that tool we used in your word problem to measure the weight and compare the weight of Play-Doh. So if you have any Play-Doh at your house, now would be a great time to get that. I have a ball of Play-Doh. See my ball of Play-Doh? It's green. I'm going to try to make it into two balls. How many of you have ever done that? Just when you're messing with Play-Doh, you take it, it's in one ball here. I'm going to try to make it into two balls. Give me just a second. I'm going to roll it up. If you're at your home, roll it, roll it, roll it, roll it, roll it, roll it, roll it. I'm going to get another one. Roll it, roll it, roll it, roll it, roll it, roll it, roll it. So look at my two balls of Play-Doh. They're about the same size. They're a little lumpy. I should have done a little bit more rolling. I'm going to give you just a second to make sure you have yours rolled. Now I've gotten out my balance scale. I'm going to put the two balls on each side of the scale. So I'm going to blow up my screen here so you can see a little better. So there's my balance scale, and we talked about this is a tool used to compare measurements. So here's my two balls of Play-Doh that I made. So I'm going to put them in the scale, and I'm going to give you just a second to make some observations. When you're making those observations, I want you to use some of your academic vocabulary of heavier than, lighter than. Discuss that with someone at your home. So what do you think? Are the balls the same weight? Which one's lighter and which one's heavier? I'm going to blow up my screen again so you can see just a little bit better. Are they the same weight? Look at how this part of the balance is bent down and this part of the balance is tilted up. That symbolizes that those aren't the same weight. So we'll call this ball A and this ball B. Talk with someone at your home. Which one do you think is heavier? Ball A or ball B? All right, so if you're looking here, ball B is heavier because this one is pulled down further. So what I really want to do, I want to see if I can balance this thing and make these equal. To be equal, the dial will need to be right there into the middle where they're the exact same weight, okay? So I'm going to start moving pieces of this Play-Doh over to this side until I can get them to balance up. Still need some more. Make sure my clay stays in the middle of there so my measurements are equal. No, that might have been too much. So I'm going to come back, put a little on each side. Let's see if it balances out. I'm going to blow it up and let y'all tell me what y'all think if it finally balanced out. No, not quite yet. Let's see. I think I got this side a little heavy now. I'm going to move a little bit over here. And it looks like we have it. And I know that they're the same weight because the scale is balanced. It looks the same on both sides. Now that we've discovered that they're balanced, I'm going to take them out. I'm going to get all their little pieces out. And I'm going to make them into one ball on each side. All the pieces, make them into one ball. Now, all the same Play-Doh is over here and all the same Play-Doh is over here. There's just no additional pieces down here where I had to spread them apart. So do you think they're going to still weigh the same? Do we have the same amount of Play-Doh still on each side? Let's see. And we got to give it a second to level out. And it looks like our balance is still the same. So no matter whether the Play-Doh was in several little pieces or whether it was in a solid form, we still had the same amount of Play-Doh on either side, so it kept the balance the same. Now, how many of you have ever taken a ball of Play-Doh and changed it into a pancake? Any of you? Oh, you have? Well, what do you think will happen? Will this scale stay balanced if I change these balls into pancakes? Talk with someone at your home. Tell me what you think. Will these balls stay balanced if I change the shape from a ball to a pancake? Take a minute to talk to someone at your home. So let's investigate. Let me try. So here's my ball, and now I'm flattening it out into a nice, yummy Play-Doh pancake. Look at that Play-Doh pancake. There's one, and it's going to stay on this side where it was. Now I have my other ball, and I'm going to flatten it into a nice, flat Play-Doh pancake. So I took the same amount of Play-Doh, I just changed its shape. And we want to see if it's going to continue to be balanced on our scale. So there's the first side. And if you notice, this side has Play-Doh in it and this side doesn't have any. So it's not balanced yet. Now let's put this one in there and see if it stays balanced even though we changed its shape. Oh, hold on. I didn't put that one in there evenly. Now let's see. Was your guess right? Make an observation. Is the scale still balanced? You're right, it is, because it's the same amount of Play-Doh. Whether they were in a ball form or a ball with a couple extra pieces or a pancake, we had the same amount of Play-Doh. Now, let's try another experiment. I'm going to take one of my pancakes and I'm going to make it into 3 small little balls. Same Play-Doh, same amount. I just took my pancake and I'm going to take it. I'm going to make it into 1. Same Play-Doh. 2. 3 smaller balls. Did the weight change or stay the same? The weight stayed the same because you have the same amount of Play-Doh on this side that you started with and the same amount of Play-Doh on this side that you started with. We just changed the shape of the Play-Doh. We didn't take any away and we didn't add any. We just changed the shape. So one thing we should have gathered from that lesson is that for a scale to be balanced, it has to have the same amount on each side. The shape can be different. You just have to have the same amount. So let's look at this worksheet here. Draw a line from the balance to the linking cubes that will weigh the same. Remember, it has to have the same on each side. So let's look over here. We have 1, 2, 3. Take a minute and look over here and see if you see one that has 3. Very good. It's this one. There's 1, 2, 3. So I'm going to draw a line to match those. Now this one has how many? 1, 2, 3, 4. So we need to find 4 to go on this side. They don't have to look just like that, but they have to be the same amount. So we have 1, 2, 3, 4. Which one of these has 4? You're right, the top one. There's 1, 2, 3, 4. So those balances would be equal. On this balance, we have 1, 2, 3, 4, 5, 6. Which one of these have 6 on this side? Remember, it doesn't have to be the same shape, just the same amount. Very good. It's this one. 1, 2, 3, 4, 5, 6. So we want to match these. And our last one, man, how many does that have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's count this one. Even though it's a different shape, we want the numbers to match. It has to have the same amount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thank you for joining me for the lesson today. I hope you enjoyed it.